Hello learners, welcome to this session. In the earlier session, we had watched the complete overview of the computer networks. What networks are, what are their characteristics features, the architecture part, the types of networks and then the topologies. And while ending that particular session, we had just seen the brief of the internet. In this session, let us focus on history of internet. I am Professor V. V. Subramaniam, Director, School of Computer Information Sciences, IGNOU, New Delhi. The internet has revolutionized many aspects of our daily lives. It has affected the way we do business as well as the way we spend our leisure time also. Count the ways you have used the internet recently. Perhaps you have sent an email to a business associate, paid a utility bill like an electricity bill, water bill or else telephone bill, read a newspaper, that too breaking news from a distant city, or looked up a local movie schedule all by using the internet. You might have researched a medical topic, an engineering topic, or else you had searched for the latest movie or done hotel reservation, chatted with a peer or compared some like products using the online e-commerce. The internet is a communication system that has brought a wealth of information to our fingertips and organized it for our use. So, the recent growth of the internet and the WWW makes it appear that the world is witnessing the arrival of a completely new technology. In fact, the web now considered to be a major driver for the way the society access and view the information. Researchers were working from 1960 to 2000, that is 4 decades, and the projects produced communications protocols that define the format of network messages, prototype networks and application programs such as browsers. So, this research capitalized on the ubiquity of the nation's telephone network, which provided the underlying physical infrastructure upon which the internet was built. Approximately 15 years after the first computers became operational, researchers began to research that an interconnected network of computers could provide services that transcended the capabilities of a single system. At this time, computers were becoming increasingly powerful and a number of scientists were beginning to consider applications that went far beyond simple numerical calculation. The history of internet is divided into 4 distinct periods. It starts way back from 1960s till 2000. So, before 1970, individual researchers developed the underlying technologies including the queuing theory, packet switching and routing. During 1970s, experimental networks, notably Advanced Research Projects Agency, in short you can call it as the ARPANET, ARPANET, in the Department of Defense. It was constructed during 1960s, end of 1969 it seems. These networks were primarily research tools and not the service providers those times. It was interested in finding a way to connect computers so that the researchers they funded could share their findings, thereby reducing costs and eliminating duplication of effort. During 1980s, networks were widely deployed initially to support scientific research. As their potential to improve personal communications and collaboration became apparent, additional academic disciplines and industry began to use the technology. In this era, the National Science Foundation, that is NSF, was the major supporter of networking, primarily through the NSF net, which evolved into the internet. Most recently, that is in the early 1990s, the invention of the web made it much easier for the users to publish and access information, thereby setting off the rapid growth of the internet. So, let us see a brief history. In 1967, at an Association for Computing Machinery, also called as ACM, in a meeting, ARPA presented its ideas for ARPANET, a small network of connected computers. The idea was that each host computer would be attached to a specialized computer called an interface message processor, that is IMP. The IMPs in turn would be connected to another IMP. So, each IMP had to be able to communicate with other IMPs as well as with its own attached host. So, by 1969, ARPANET was a reality. 4 nodes at University of California at Los Angeles, UCLA, the University of California at Santa Barbara, that is UCSB, Stanford Research Institute, that is SRI, and the University of Utah were connected via the IMPs to form a network. Software called the Network Control Protocol NCP provided communication between these hosts. So, these were the first 4 nodes connected using this ARPA experiment. So, coming to the TCP IP. So, this is the major protocol that will be used in the internet. So, TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. So, this is the model or else a reference model that will be used by the internet. In 1972, Windsurf and Bob, both of whom were part of the core ARPANET group, collaborated on what they call the interneting project. So, Surf and Khan landmark 1973, a paper outlined the protocols to achieve end-to-end delivery of packets. This paper on transmission control protocol included the concepts such as encapsulation, the datagram and the functions of a gateway. Shortly thereafter, authorities made a decision to split TCP into 2 protocols. One is Transmission Control Protocol, that is TCP, and Interworking Protocol, that is IP, Internet Working Protocol, that is IP. So, IP would handle datagram routing while TCP would be the responsible for higher level functions such as segmentation, reassembly and error detection. So, within these particular 2 protocols, the work is being distributed. One is handling the datagram routing and the other is handling the segmentation, reassembly and error coding. So, the internet working protocol became known as the TCP IP. So, let us see internet today. The internet has come a long way since 1960s. The internet today is not a simple hierarchical structure. It is made up of many wide and local area networks joined by connecting devices and switching stations. So, right now there are several billion nodes connected to the internet. It is difficult to give an accurate representation of the internet because it is continuously changing the way the networks are being added to the existing networks and the addressing system is being added and it is being enhanced. Today most end users who want internet connection use the services of internet service providers. So, there are international service providers, national service providers, regional service providers and local service providers. So, it is a kind of hierarchy right from international level to the local level. So, the internet today is run by private companies and not lying with any kind of government control. So, let us see the hierarchy of the providers. In the earlier slide, we had seen right from the international to the local service providers. Let us focus on one by one. So, international internet service provider, at the top of the hierarchy are the international service providers that connect nations together. So, these service providers, the major task is to connect the networks from one nation to the other nation. So, next comes in the hierarchy, that is the national internet service providers. So, these are nothing but they will be looking into the national aspects of connecting. So, the national internet service providers are backbone networks created and maintained by specialized companies. There are many national ISPs operating within every nation. To provide connectivity between the end users, these backbone networks are connected by complex switching stations normally run by a third party called network access points. In short, you can call it as the NAPs. Some national ISP networks are also connected to one another by private switching stations called peering points. So, then comes the regional internet service providers. Regional internet service providers or regional ISPs or smaller ISPs, those are connected to one another, one or more national ISPs. They are at the third level of the hierarchy with a similar data rate. International service provider till the local service providers, they will be playing with different data rates. So, this will be at the third hierarchy, and then the final in the list is the local internet service provider. Local internet service providers provide direct service to the end users. The local ISPs can be connected to regional ISPs or directly to national ISPs. Most end users are connected to the local ISPs. Note that in this sense, a local ISP can be a company that just provides internet services, a corporation within a network that supplies services to its own employees, or a non-profit organization such as a college or a university that runs its own network. Each of these local ISPs can be connected to a regional or national service provider. So, with this backdrop, let us study the TCP/IP reference model. In our earlier video, we had studied two models briefly. One is the OSI reference model and the other is the TCP/IP reference model. There we had studied OSI a bit detailed. It consists of several layers. So, right from the application layer till the present like a physical layer, we had seen all the 7 layers and how they will be coordinating and what are the various tasks associated with the each and every layer of the OSI that we had studied in our earlier video. In this video, let us focus on the important reference model for internet, that is the TCP/IP reference model. The TCP/IP reference model was developed prior to the OSI model. The major design goals of this model were to connect multiple networks together so that they appear as a single network, that is the first objective. Second is to survive after partial subnet hardware failures, and the third is to provide a flexible architecture. So, these are the three objectives that were kept for design of the TCP IP reference model. So, there are altogether 4 layers in the TCP IP. Unlike OSI reference model, it was having 7 layers. TCP reference model has only 4 layers. They are host to network layer, internet layer, transport layer and application layer. So, let us see how these layers are being placed and what are the various tasks each and every layer take up. Host to network layer, that is the first layer. The TCP IP reference model does not really say much about what happens here, except to point out that the host has to connect to the network using some protocol, so it can send IP packets to it. So, this protocol is not defined and varies from host to host and network to network. In the list, the second layer is the internet layer. So, this is the prominent layer among the TCP IP reference model. This layer called as the internet layer is the linchpin that holds the whole architecture together. Its job is to permit hosts to inject packets into any network and have they travel independently to the destination. They may even arrive in a different order than they were sent, in which case it is the job of higher layers to rearrange them if in order delivery is desired. So, note that internet is used here in a generic sense, even though this layer is present in the internet. The internet layer defines an official packet format and protocol called IP, that is internet protocol. The job of the internet layer is to deliver IP packets where they are supposed to go. Packet routing is clearly the major issue here, as is avoiding congestion. For these reasons, it is reasonable to say that the TCP IP internet layer is similar in functionality to the OSI network layer. So, it can be treated as network layer in the OSI model. So, next comes the transport layer. The layer above the internet layer is the TCP IP model, is now usually called the transport layer. It is designed to allow peer entities on the source and the destination host to carry on a conversation just as in the OSI transport layer. Two end-to-end transport protocols have been defined here. The first one is the TCP. It is reliable connection oriented protocol that allows a byte stream originating on one machine to be delivered without error on any other machine in the internet. It fragments the incoming byte stream into discrete messages and passes each one onto the internet layer. At the destination, the receiving TCP process reassembles the received messages into the output stream. TCP also handles flow control to make sure a fast sender cannot swamp a slow receiver with more messages than it can handle. The second protocol in this layer, that is UDP, and the full form is User Datagram Protocol. It is an unreliable connectionless protocol for applications that do not want TCP sequencing or flow control and wish to provide their own. It is also widely used for one-shot client server type request reply queries and applications in which prompt delivery is more important than accurate delivery, such as transmitting speech or video. So, in the application layer, the TCP IP model does not have a session or presentations layer. So, these two are missing in the TCP IP layers. On top of the transport layer is the application layer. It contains all the higher level protocols. The early ones included virtual terminal, or telnet, you can call it, or else file transfer, it is in short called as FTP, and electronic mail, or else you can call it as SMTP. So, the virtual terminal protocol allows a user on one machine to log on to a distinct machine and work there. The file transfer protocol provides a way to move data efficiently from one machine to other. Email was originally just a kind of file transfer, but later a specialized protocol, that is SMTP, was developed for it. Many other protocols have been added to these over the years, that is the domain name system, you can call it as the DNS for mapping host names onto their network addresses, NNTP, the protocol for moving Usenet news articles around, and HTTP, the hypertext transfer protocol, the protocol for fetching pages on the World Wide Web, and many others. So, these are the 4 layers which comprises of the TCP/IP reference model. So, after that, the major focus that we can throw is the World Wide Web. In short, we can call it as the WWW. The majority of internet users do not start up their computers and log on to the ARPANET. We usually open our browsers and start typing www, that is www. So, www stands for World Wide Web, and this web is one of the most important innovations that the internet has seen in its relatively short life. The World Wide Web is pretty much a platform that makes it easy to access data on the internet. The WWW uses hypertext links, which are pieces of code that links one site to another. Using a browser, you can easily access a link by clicking a mouse, essentially moving from one computer to another located on a web with a single click. Most of today's computer users access the internet via a browser, whether it may be a Google browser, Microsoft's Internet Explorer, Mozilla's Firefox, or other browsers. The browser itself helps a user to not only access the data but view it. Today, via the web and a browser, you can view text and other types of media and navigate easily from one page to another utilizing hypertext links. Let us see the brief history of WWW. The WWW was actually created in 1989 by Sir Tim Berners-Lee, Sir Sam Walker, and Robert Callio. They are doing research in CERN, that is European Organization for Nuclear Research. However, the World Wide Web was introduced publicly on August 6, 1991. This is when the internet finally took off. The WWW was one of several types of platforms developed for the internet that utilized hypertext systems. While others existed in the early 90s, there were a few reasons that the web took off in a popularity and use. First off, hypertext links on the web platform did not need to be bidirectional, they could be one-way links. And perhaps the biggest reason that the web took off was that it was free. It did not require licensing restrictions. Other platforms required special hardware, and this hardware and the use of software cost money, making many organizations to choose the free alternative. So, the next important client part that we can discuss is the browsers part. So, in the client server architectures, these browsers become the part of the client. So, while Mosaic and then Netscape were dominant in the early to mid 90s, as more and more of the public using Microsoft Windows software on their home computers started to go online, Microsoft started a browser called as the Internet Explorer. So, Microsoft was extremely effectively in prompting their Internet Explorer browser. In fact, they did this by bundling the software with their operating system itself, most notably the famous operating system, that is the Windows 98. While Netscape had about 85% of the browser share in the mid 90s, and by 2003 Netscape was used by less than 1% and is now defunct altogether. Today, Internet Explorer is still the dominant browser used by Windows computers. However, they are also about to vanish from the browser's perspective. Most of the people, we are now using Google, Firefox and other open source browsers. So, in this particular list, you have the Safari, Opera and other kinds of browsers adding on to the list of the browsers. So, apart from this particular history of the internet, you have several advantages and the applications of the internet. Nowadays, without the internet, nobody can do anything online. So, after the big e-commerce is nowadays very much popular. So, most of the people, they are purchasing the products using the e-commerce systems. There are several e-commerce which are very much popular like Amazon, Flipkart, Snapdeal, etc., wherein which most of the people not wasting much time by going physically and buying the products. Most of the people, they are buying the products online. Apart from this particular e-commerce companies, in the education also, most of the people, they are using the online technologies. And then during the COVID time, so you have experienced that most of the education has been transacted through the internet medium. Many video conferencing were happening, webinars were happening, kids are participating in the video conferencing by taking the classes online, teachers are teaching classes online, and there was huge usage of internet during the COVID time also. So, with this, I hope you had understood the topics related to history of internet, the TCP/IP reference model, the history of www, the browsers and the applications of the internet. In the next session, let us see how to connect to the internet through various means. Thanks for watching. Thank you.